For all of human history, the moon has been our silent silver companion in the night sky. It's a source of mystery, myth, and inspiration. But of all the ideas we hold about it, one has captured our imagination more than any other: the dark side of the moon. We imagine a hidden realm of perpetual night, a concept so powerful it's woven into our art and language. It's a compelling idea, but it's also a complete myth. The truth is, the dark side of the moon simply doesn't exist, and the reality is far more fascinating. The reason for this misconception comes from a phenomenon called tidal locking, or synchronous rotation. Billions of years ago, when the moon was a young molten ball of rock, it spun on its axis much faster than it does today. Earth's powerful gravity exerted a relentless pull on it, creating tidal bulges and generating immense internal friction. This friction acted as a brake, continuously slowing the moon's rotation over millions of years. Eventually, its spin slowed just enough to perfectly match the time it takes to orbit our planet. Today, the moon takes about 27.3 days to spin once on its axis, and it takes the exact same amount of time to complete one full orbit around the Earth. Because its rotation and orbit are perfectly synchronized, it is locked in a gravitational embrace, always presenting the same face towards us. Think of a dancer who keeps their face pointed towards a partner while circling them. They must complete one full spin of their own for every lap they take. The moon is locked in this same cosmic dance with Earth. This is why we only ever see one side, the familiar, landscape astronomers call the near side. But the crucial point is that the side we don't see isn't dark. It's simply the far side. The far side of the moon receives just as much sunlight as the near side. It experiences its own cycle of day and night, each lasting about 2 Earth weeks. When we see a new moon in our sky, meaning the near side is dark to us, the far side is experiencing its version of a bright, fully illuminated high noon. Conversely, when we see a full moon, the far side is plunged into its long 2-week night. It's not a place of permanent darkness, but a place of permanent hiding from our vantage point. For most of history, the nature of this hidden half was a complete mystery. It wasn't until 1959 that the Soviet Luna 3 probe gave humanity its first grainy glimpse. The images revealed a landscape starkly different from the side we knew. The near side is dominated by vast, dark plains of ancient lava called Maria, which create the illusion of the man in the moon. The far side, however, is almost entirely devoid of these features. It is a more ancient, rugged, and brutal landscape, saturated with countless overlapping craters. But the story doesn't end there. Debunking the dark side is only the first layer of the secret. The second, more subtle layer is that the moon isn't perfectly locked. As it travels, it gently nods and wobbles from our perspective, a phenomenon called lunar libration. This wobble allows us to peek around its edges over time. This libration happens for 3 main reasons. First, the moon's orbit is not a perfect circle, but an ellipse. This means it moves faster when it's closer to Earth and slower when it's farther away. Since its rotation speed remains constant, its varying orbital speed lets us see a little extra around its eastern and western edges. It's as if it's slowly turning its head from side to side. Second, the moon's axis is slightly tilted relative to its orbit. Much like Earth's tilt gives us seasons, the moon's tilt means that as it travels, we can sometimes see a little bit over its north pole, and, at other times, a little bit under its south pole. It's as if it's gently nodding yes to us. Finally, a tiny wobble is caused by our own perspective here on Earth. As our planet rotates over a 24-hour day, your position as an observer moves by thousands of miles. This creates a small parallax effect, allowing you to see the moon from slightly different angles and revealing just a sliver more of its surface. So, when you combine these 3 librations, this gentle cosmic wobble, the result is astonishing. Over the course of a month, we don't just see 50% of the moon, we actually get to see a grand total of 59% of its surface. That's the real secret. It's not that there's a dark side, it's that the moon, our closest celestial neighbor, only manages to keep 41% of its surface truly and permanently hidden from a direct line of sight from Earth. For millennia, humanity stared up at what we thought was a fixed, unchanging face, completely unaware that it was subtly revealing more of itself to us all along. A hidden gift from the beautiful complexities of orbital mechanics. The moon is a master of secrets, hiding them not in darkness, but in plain sight. So we've uncovered the truth about the moon's face. But what about its shape? While it looks like a perfect sphere hanging in our sky, its true form is something far stranger, and it's a secret that will change the way you look at it forever. In our last chapter, we peeled back the first layer of lunar mystery, revealing that the dark side of the moon is a myth, and that our constant companion shows us more of its face than we ever thought possible. We are left with a new appreciation for the complex dance of orbits and gravity, but that dance has left its mark on the moon in other even stranger ways. When you look up at the night sky, what shape is the moon? The answer seems obvious. It's a perfect circle, a flawless silver coin, or a glowing pearl suspended in the blackness of space. For our entire lives, we see it as the very definition of roundness. All of our drawings, icons, and mental images depict it as a perfect sphere. But what if that perfect circle is just another illusion? A trick of distance and perspective that masks a much stranger reality. Prepare to have your perception of our nearest neighbor reshaped, because the second great secret of the moon is that it isn't a sphere at all. Its true shape is something far more peculiar. A slightly squashed, oddly shaped ovoid that scientists have best described as being like a lemon. To understand how the moon got this strange, lumpy shape, we have to travel back in time to its chaotic youth. When the moon first formed, it was a hot, molten body, and it was spinning on its axis much, much faster than it does today. Just like a spinning ball of pizza dough flattens out and spreads at its edges, the immense centrifugal force of the moon's rapid spin caused it to bulge at its equator and become slightly flattened at its poles. This is the same reason Earth is not a perfect sphere. It too bulges at the equator. The moon's spin has slowed dramatically since then, but because it solidified while it was still spinning quickly, this equatorial bulge is essentially frozen in time. It's a fossil bulge, a permanent relic of its ancient, frantic rotation. But that's only part of the story. That initial flattening explains why it's an oblate spheroid, but it doesn't explain the lemon shape. That comes from another force we've already met: the immense and relentless gravity of the Earth. As we learned, Earth's gravity is what slowed the moon's rotation and locked it into its synchronous orbit. But that gravitational pull does more than just control its spin. It physically stretches the moon itself. The force of Earth's gravity is strongest on the side of the moon closest to us, and weakest on the side farthest away. This difference in gravitational pull, known as a tidal force, causes the moon's body to elongate along a line pointing directly towards the Earth. It creates a permanent tidal bulge on the near side, pulled towards our planet, and a corresponding bulge on the far side, which is essentially left behind as the rest of the moon is pulled away from it. So, imagine these two immense forces working together over billions of years. First, the moon's ancient rapid spin flattened it at the poles and caused it to bulge at the equator. Then, as it solidified, the Earth's constant gravitational pull stretched it, creating two more bulges on its near and far sides. When you combine the flattened poles with these two tidal bulges, you don't get a sphere. You get a lumpy, oblong shape, slightly pointed at the ends facing towards and away from Earth, and slightly flattened on the top and bottom. A shape very much like a lemon lying on its side. Of course, this is an exaggeration. The moon's deviation from a perfect sphere is tiny, far too small to be seen with the naked eye from 240,000 miles away. That's why it looks so perfectly round to us. We couldn't confirm this strange shape with telescopes alone. The secret was unlocked by modern space exploration. Missions like NASA's Clementine and Lunar Prospector, and especially the twin spacecraft of the Grail mission, didn't just take pictures. They precisely mapped the moon's gravitational field. By measuring the tiny pushes and pulls on the orbiting spacecraft, scientists could create a detailed map of the moon's mass, revealing where it was denser, lumpier, and ultimately, what its true shape was. The moon's shape is more than just a quirky piece of trivia. It's a geological time capsule. It tells the story of its own violent and dynamic past, of its fiery birth, its ancient, rapid spin, and the immense gravitational battle with Earth that slowed it. locked it, and stretched it into the unusual form it holds today. So, the next time you gaze up at the full moon, remember what you're truly seeing. It's not a flat silver disk. It's not even a perfect marble-like sphere. You are looking at a complex, squashed, lemon-shaped world, a celestial body sculpted and frozen by the unimaginable forces of its youth. Now that we understand its strange shape, what about the familiar face etched onto its surface? The features we call the man in the moon or the rabbit are not random markings. They are vast scars from a fiery volcanic past that tell another incredible story. In our journey so far, we've learned that the moon doesn't have a dark side, merely a far side, and that its seemingly perfect spherical shape is an illusion masking a lumpy, lemon-like form. We are beginning to see that the moon we think we know is not the moon that truly is. Now, we turn our attention to its most familiar feature, the face that has stared back at humanity for millennia. Across cultures and throughout history, people have gazed up and seen patterns in the moon's patches of light and shadow. In the West, many see the man in the moon, 2 large eyes, a nose and a mouth. In East Asia, many see a rabbit pounding rice in a mortar. Other cultures have seen a woman weaving, a giant crab, or a woman reading a book. This universal human tendency to perceive familiar patterns, especially faces, in random arrangements is a psychological phenomenon known as pareidolia. It's the same instinct that allows us to see animals in the shapes of clouds or a face on the front of a car. But while our brains are responsible for interpreting these shapes, the shapes themselves are very real. What are those dark and light patches physically? What created the cosmic ink that allows us to draw these pictures in our minds? The answer lies not in myth or magic, but in a history of unimaginable violence and planetary-scale volcanism. The face on the moon is a scar, a remnant of a fiery and chaotic past. To understand it, you must first know that the lunar surface is composed of 2 fundamentally different types of terrain. The bright, reflective areas are known as the lunar highlands. These are the moon's original primordial crust. Formed over 4 billion years ago, they are composed of a light-coloured, feldspar-rich rock called anorthosite. Think of the highlands as the moon's ancient continents. They are rugged, mountainous, and completely saturated with craters, bearing the scars of the late heavy bombardment, a period in the early solar system when asteroids and comets rained down relentlessly. The dark areas, on the other hand, are the features that create the face. Early astronomers like Galileo, peering through the first telescopes, mistakenly thought these smooth, dark patches were oceans and seas. They named them Maria, the Latin word for seas. We see the Mare Tranquillitatis, the Sea of Tranquility, or the Mare Imbrium, the Sea of Rains. But these are not, and never were, bodies of water. The Maria are vast flat plains of dark volcanic rock called basalt, very similar to the hardened lava found in places like Hawaii and Iceland on Earth. The story of how they formed is a 2-act play of cosmic destruction and creation. The first act began nearly 4 billion years ago. The moon was struck by a series of colossal asteroids, some hundreds of kilometers wide. These impacts were so powerful that they didn't just leave craters. They gouged out enormous, multi-ringed depressions called impact basins and fractured the moon's crust for hundreds of kilometers below the surface. The second act began much later. For hundreds of millions of years after these impacts, the moon's interior was still incredibly hot, heated by the decay of radioactive elements within its mantle. This heat melted vast quantities of rock deep beneath the surface, creating immense chambers of magma. This molten rock, being less dense than the solid rock around it, began to well up, seeking a path to the surface. It found that path through the deep fractures created by the earlier asteroid impacts. What followed were some of the largest volcanic eruptions in the history of the solar system. But lunar volcanism was nothing like the explosive cone-shaped volcanoes we see on Earth. The moon has much lower gravity and no atmosphere to hold gases in. This meant the lunar lava was incredibly fluid and runny, more like hot oil than the thick molasses-like lava of Earth. When this magma reached the surface, it didn't build mountains. Instead, it erupted from long fissures and flooded the low-lying impact basins. For millions of years, these basins were filled with immense seas of flowing, molten rock, which spread out to create vast, incredibly smooth plains. Eventually, this lava cooled and solidified into the dark basalt rock we see today, forming the Morea. Because these lava flows happened after the worst of the late heavy bombardment was over, the Morea have far fewer craters than the ancient highlands, which is why they appear so smooth in comparison. So, the man in the moon is nothing more than an illusion created by the stark contrast between the two terrains. The bright, ancient, rugged, crater-saturated highlands and the dark, younger, smooth volcanic Morea. The two eyes we see are the vast lava plains of the Sea of Rains and the Sea of Serenity. The rest of the face is formed by other Morea, outlined by the bright highlands around them. The next time you look at the moon, try to see it not as a face, but as a history book. You are witnessing a landscape forged by fire and stone, a canvas painted by cataclysmic impacts and flooded with oceans of ancient lava. The familiar face is a beautiful accident of geology, a timeless reminder of the violent and creative forces that shape worlds. We've explored the secrets of the moon's face and its strange, lemon-like shape. We've seen how its surface tells a story of ancient lava flows and colossal impacts. But what about the space just above that surface? For decades, science and science fiction have painted the same picture. The moon exists in a perfect, absolute vacuum. It's a place so devoid of air that an astronaut's footprint will remain perfectly preserved for millions of years, untouched by even the slightest breeze. This image of a silent, airless world is fundamental to how we imagine the moon. But that too is another profound misconception. The fourth great secret is that the moon is not surrounded by a perfect vacuum. It has its own atmosphere. Now, before you imagine clouds drifting over the sea of tranquility, we must be clear. The lunar atmosphere is nothing like the dense, life-sustaining blanket of air we have on Earth. You couldn't breathe it. It offers no weather, no sound, no blue sky, and virtually no protection from the harsh radiation of space. It is so incredibly thin that scientists don't even call it an atmosphere in the traditional sense. The proper term is a surface boundary exosphere. On Earth, the exosphere is the final, outermost layer of our atmosphere, beginning hundreds of kilometers up, where our air gradually fades into the vacuum of space. There, gas molecules are so far apart that they can travel for long distances without colliding with one another. On the moon, that same incredibly sparse environment exists all the way down to the ground. The density of the lunar atmosphere is comparable to the most perfect vacuums we can create in laboratories on Earth. To put it in perspective, the air you are breathing right now contains about 30 quintillion molecules in a single cubic inch. The lunar atmosphere, at its densest, contains only a few million. A difference so vast it's almost impossible to comprehend. So, if it's so thin, where does it even come from? An atmosphere, no matter how tenuous, needs a source. The moon's ghostly exosphere is not a permanent feature, but a dynamic system that is constantly being generated by several processes at once. One source is outgassing from the moon's interior. Although it's far less geologically active than Earth, the moon is not completely dead. The slow decay of radioactive elements, like potassium and uranium deep within its crust and mantle, still produces gases. These gases, primarily helium, argon, and radon, gradually seep up through cracks in the lunar rock and are released from the surface. It's a very slow, subtle form of planetary breathing, contributing a steady trickle of atoms into the exosphere. A far more significant source comes from the sun itself. The sun constantly emits a stream of charged particles called the solar wind, which flows outwards through the solar system at over 1 million miles per hour. Earth is protected from this onslaught by its global magnetic field, which deflects the solar wind around us. The moon has no such protection. The solar wind slams directly into the lunar surface with incredible force. This constant bombardment acts like a microscopic sandblaster, a process called sputtering. High-energy particles from the sun strike the lunar soil, or regolith, and physically knock individual atoms loose, kicking them up into the exosphere. This process is responsible for adding elements like sodium and potassium to the lunar atmosphere. In fact, this sputtering is so effective that it gives the moon a faint, comet-like tail made of sodium gas, stretching for hundreds of thousands of miles, visible only with specialized instruments. Finally, the lunar atmosphere is also fed by a constant rain of micrometeorites. The same lack of a thick atmosphere that preserves footprints also means there is nothing to burn up incoming space debris. The moon is continuously pelted by tiny dust particles from comets and asteroids. When these particles strike the surface at immense speeds, the impact generates a flash of intense heat, vaporizing a small amount of both the impactor and the lunar soil. This process releases a puff of various atoms and molecules, adding to the ever-changing exosphere. This ghostly atmosphere exists in a delicate balance between creation and destruction. The moon's gravity is too weak to hold onto these gases for long. An atom in the exosphere doesn't float. It flies on a ballistic trajectory, like a ball thrown in the air, before eventually falling back down to the surface. But before it can, it's likely to be stripped away forever by the pressure of solar radiation, or swept up by the solar wind. This is why the lunar atmosphere never builds up. It is a transient, shimmering veil, constantly being born from the rock below, and relentlessly scoured away by the forces of space. So, the moon is not truly in a vacuum. It is surrounded by a dynamic, incredibly thin haze of atoms, a ghostly breath born from its own slow decay, and the relentless bombardment from the cosmos. It reminds us that no corner of the solar system is truly empty, and even the most desolate worlds have their own hidden, active processes. In our last chapter, we discovered the moon's ghostly transient atmosphere, a shimmering veil of atoms born from the moon's own decay and the relentless bombardment from space. Those constant impacts from micrometeorites don't just kick up gas, they fundamentally and permanently change the very soil of the moon, transforming its surface into something unexpected, dangerous, and beautiful. When we picture the lunar landscape, we imagine a world of grey dust and rocks. We see the iconic images of the Apollo astronauts' boots pressed into a fine, soft-looking powder, leaving prints that will last for ages. But what is that dust actually made of? It isn't soil, not in any way we would recognize it on Earth. It's not the product of gentle erosion by wind and water, and it contains no organic matter. It's a substance with a different name and a violent origin. The fifth great secret of the moon is that its surface is, to a large extent, covered in glass. The proper term for the moon's soil is regolith. It's a thick blanket of loose, pulverized material that covers the solid bedrock below, created by over 4 billion years of continuous meteorite and micrometeorite impacts. This constant churning has ground the surface down into a mixture of fine dust and sharp, jagged rock fragments. But the incredible energy of these impacts does more than just crush rock. It melts it, and when molten rock cools very, very quickly in the airless, frigid vacuum of space, it doesn't have time to form crystals. It solidifies as glass. This glass-making process happens in two main ways. The first is through ancient volcanism. As we learned, vast seas of lava once flooded the moon's surface to form the Maria. Some of these eruptions were incredibly violent, driven by dissolved gases in the magma. When this molten rock burst onto the vacuum of the lunar surface, it created what scientists call fire fountains. These were colossal sprays of magma, flinging tiny droplets of lava high above the surface. In the vacuum, these molten droplets cooled and solidified in mid-flight before ever touching the ground. They hardened into perfect, microscopic spheres and teardrops of glass. The most famous example of this was discovered by the Apollo 17 mission. Astronaut and geologist Harrison Schmitt was astounded to find a patch of vibrant, orange soil near their landing site. When this sample was brought back to Earth, analysis revealed it was composed almost entirely of tiny orange and black volcanic glass beads, the remnants of a fire fountain that erupted over 3.5 billion years ago. However, the most common way glass is formed on the moon is through the constant, ongoing bombardment of its surface. Every single day, the moon is pelted by a relentless shower of micrometeorites. These are particles often no bigger than a grain of sand, but they travel at incredible speeds, tens of thousands of miles per hour. The energy released in these hypervelocity impacts is immense, generating temperatures hotter than the surface of many stars for a fraction of a second. This intense, localized heat instantly melts the silica-rich lunar regolith at the point of impact. The explosion blasts this molten material outwards, and just like with the volcanic fire fountains, the tiny droplets cool and solidify almost instantly in the vacuum, forming countless microscopic glass spherules. This process has been happening continuously for billions of years, all over the Moon, constantly churning the regolith and enriching every handful with tiny glass beads. But it gets even more complex. The impacts don't just create simple glass spheres. They also create one of the most common and strangest components of the lunar regolith, particles called agglutinates. An agglutinate is formed when a micrometeorite impact melts a small amount of soil. This molten glass then fuses together surrounding rock fragments, dust particles, and other glass beads into a single, twisted, composite particle. Agglutinates are like microscopic, glassy sculptures, welded together by the heat of an impact. They are often dark, jagged, and incredibly sharp. This is why lunar dust is so dangerous. It's not a soft powder, it's a harsh abrasive, full of sharp pulverized rock and these tiny glassy daggers. During the Apollo missions, the dust clogged equipment, abraded spacesuits, and caused irritation for the astronauts. Its sharp glassy nature makes it a major engineering challenge for any future lunar colonization. So, the soft-looking grey dust of the Moon is a deceptive facade. It is a complex and hazardous material, a testament to its violent history. Billions of years of volcanic fire and cosmic bombardment have transformed its surface into a landscape peppered with tiny, beautiful spheres of coloured glass and sharp, dangerous glassy fragments. It's a world where the very ground beneath your feet is a mixture of jewels and daggers. A beautiful and harsh reminder of the forces that shape our celestial neighbour. The glass on the Moon's surface tells a story of constant, small-scale violence. But the Moon itself owes its very existence to a single cataclysmic impact of unimaginable scale. To truly understand our Moon, we must ask the most fundamental question of all. Where did it come from? For centuries, this was one of science's greatest puzzles, and the journey to the answer is a story of incredible discovery. For a long time, there were three leading ideas. The fission theory suggested that the early Earth was spinning so rapidly that a large blob of its molten material flung off into space and became the Moon. The capture theory proposed that the Moon was a wandering body, like an asteroid, that drifted too close to Earth and was snared by our planet's gravity. The co-accretion theory argued that the Earth and Moon simply formed together, side by side, from the primordial cloud of gas and dust that created our solar system. Each of these theories had its merits, but none of them could explain all the facts. The physics didn't quite work for fission. The chemical similarities between Earth and the Moon made a random capture seem impossibly coincidental. And co-accretion couldn't explain why the Moon has such a tiny iron core compared to Earth. For decades, the origin of the Moon remained a deep mystery. The truth, when it was finally pieced together, was far more spectacular and violent than anyone had imagined. The sixth great secret is that the Moon is the child of a planetary catastrophe. It was born from the wreckage of a collision that nearly destroyed our world just after it formed. This is the giant impact hypothesis. Let's set the scene. The time is 4.5 billion years ago. The solar system is a chaotic, crowded shooting gallery of newly formed protoplanets, all jockeying for position and sweeping up debris in their orbits. Our own proto-Earth was one of these young worlds, a molten ball of rock still glowing from the heat of its formation. But it was not alone. Sharing its orbit was another world, a protoplanet scientists have named Theia. Theia was roughly the size of Mars, and it was on a collision course with Earth. The inevitable happened. In an event of almost unimaginable violence, Theia slammed into the young Earth at an oblique angle, travelling at a speed of over 25,000 miles per hour. The impact was not just an explosion. It was a planetary-scale vaporization. Theia was completely obliterated. A huge portion of Earth's own crust and mantle was instantly vaporized and blasted into space, along with the remnants of Theia. What was left was a massively deformed, superheated Earth, surrounded by a colossal, orbiting ring of incandescent rock vapor and molten debris. This was not a calm, stable ring like Saturn's. It was a chaotic, searingly hot cloud of material that glowed brighter than the sun in Earth's sky. But this ring of destruction was also a cradle of creation. In the cold of space, the vaporized rock quickly began to condense and solidify. Under the force of gravity, particles of debris began to clump together. These clumps collided and merged, growing ever larger in a process that was incredibly fast by cosmic standards. Within perhaps only a few centuries, the vast majority of the material in the ring had coalesced into a single large body. A new world had been born from the wreckage of two others. This was the Moon. Initially, it was much closer to Earth than it is today, appearing gigantic and fiery in our primordial skies. This is an incredible story, but how do we know it's true? The final proof came from the rocks brought back by the Apollo astronauts. When scientists analyzed these precious samples, they found they fit the giant impact model perfectly. First, they found a unique chemical fingerprint. The ratios of different types of oxygen atoms, known as isotopes, are unique to each planet. The Moon rocks were found to have an oxygen isotope signature that was almost identical to that of Earth's mantle. This was the smoking gun, proving that the Moon is made of the same raw material as our own planet. Second, the model explained the Moon's missing iron. The Moon has a very small iron core for its size. The giant impact explains why. During the collision, the heavy, dense iron cores of both Earth and Theia merged and remained with the larger body, Earth. It was primarily the lighter silicate rock from the mantles of both planets that was blasted into orbit to form the Moon. Finally, the Moon rocks were found to be severely depleted in what are known as volatile elements. Things like water, sodium and zinc that turn to gas at relatively low temperatures. The incredible heat of the giant impact, hot enough to vaporize rock, would have easily boiled these elements away from the debris cloud, leaving the material that formed the Moon bone dry. So, the Moon is not a captured stranger or a distant sibling. It is in a very real sense a part of the Earth itself, forged in fire and violence. It is made of the stolen and reforged mantle of our own world. Every time you look up at its comforting light, you are looking at a monument to the most violent day in Earth's history, a constant reminder of the chaotic and creative forces that shape the cosmos. Our journey to understand the Moon has taken us from the illusion of its dark side to the reality of its strange, lemon-like shape. We've discovered its face is a canvas of ancient lava, its soil is peppered with glass, and its very existence is the result of a cataclysmic collision with our own planet. Through all of this, a central theme emerges. The Moon is a relic, a body shaped by ancient forces. This often leads to the popular image of the Moon as a dead world, a geologically inert, silent and unchanging ball of rock. We contrast it with our own vibrant Earth, a planet alive with the rumble of earthquakes, the shifting of continents, and the fire of volcanoes. But this image of a silent, dormant world is yet another lunar secret waiting to be shattered. The Moon is not dead. It is a world that trembles, groans and shudders with surprising frequency. The seventh great secret is that the Moon is still geologically active, experiencing thousands of seismic events, or moonquakes, every single year. This isn't just a theory, it's a recorded fact, a discovery made possible by one of the greatest triumphs of the Apollo program. Between 1969 and 1972, astronauts on the Apollo 12, 14, 15, and 16 missions deployed a network of seismometers on the lunar surface. For 8 years, until the network was switched off in 1977, these incredibly sensitive instruments listened to the faint heart murmur of the Moon, transmitting a continuous stream of seismic data back to Earth. What they heard revealed a world that was far from quiet. The data showed not just one, but 4 distinct types of moonquakes. The first and most common type are deep moonquakes. These occur very far down, about halfway to the Moon's center, and are relatively mild. For years, their cause was a mystery, until scientists noticed a distinct pattern. These quakes were not random, they were highly predictable, occurring in regular monthly cycles. The culprit was revealed to be the Earth. Just as the Moon's gravity creates tides in our oceans, the Earth's immense gravity constantly squeezes and stretches the Moon's interior. This relentless tidal stress builds up in the deep, brittle rock, eventually causing it to slip and fracture, generating a deep moonquake. The Moon trembles in rhythm with its orbit around us. The second type of seismic event is the most straightforward: meteorite impacts. With no atmosphere to protect it, the moon is constantly being hit by space debris. The Apollo seismometers recorded thousands of these impacts, ranging from small pebbles to larger objects that sent shockwaves rippling across the lunar surface. Each impact rang the moon like a gong, providing valuable data about the structure of its crust and interior. The third type of quake is perhaps the most unusual: thermal quakes. These are tiny, shallow tremors that were only detected when the sun rose and set over the Apollo landing sites. The lunar surface experiences some of the most extreme temperature swings in the solar system, from a frigid minus 280 degrees Fahrenheit at night to a blistering 260 degrees Fahrenheit in direct sun. When the sun's rays first strike the frozen lunar crust at dawn, it begins to expand rapidly. This sudden thermal stress causes the brittle surface rock to crackle and pop, creating a cacophony of tiny quakes. It is the sound of the moon's own skin stretching as it warms in the morning sun. But it is the fourth type of quake that is the most powerful and mysterious: shallow moonquakes. These occur much closer to the surface, only 20 to 30 kilometers down. They are far less frequent than deep quakes, but they are significantly more powerful, reaching up to 5.5 on the Richter scale. A quake of that magnitude on Earth could cause serious damage to buildings. And unlike the deep quakes, they don't seem to be linked to the Earth's tidal forces. Their cause remains a scientific puzzle, but the leading theory is that the moon is still slowly cooling and shrinking from the heat of its formation. As the moon's interior shrinks, its rigid crust is forced to buckle and fault, causing stress to build up over long periods until it releases in a powerful, shallow moonquake. This suggests that the moon is still tectonically active, driven by its own internal evolution. It is not a dead world, but a living one in its own right, a body stressed by the pull of its parent planet, battered by impacts from space, cracked by the daily shock of sunlight, and groaning from the slow contraction of its own core. The data from the Apollo missions gave us a brief 8-year window into the moon's hidden life, forever changing our view of it from a silent, static satellite to a dynamic and trembling world. As we delve deeper into the secrets of the moon, a recurring theme emerges: a profound lack of symmetry. We've learned its orbit is not a perfect circle, but an ellipse, causing a wobble that lets us peek around its edges. We've discovered its body is not a perfect sphere, but a tidally stretched, lemon-like shape. It seems the forces that govern the moon's youth sculpted it into an object of strange imbalances. Now, we turn our attention from its shape to its very composition, and we find what is perhaps the greatest asymmetry of all. The face of the moon we see, and the face that remains forever hidden, are not just visually different, they are fundamentally, geologically distinct worlds. This startling difference, known as the lunar dichotomy, is one of the longest-standing and most debated mysteries in planetary science. The eighth great secret is that the moon's geology is profoundly lopsided, with two hemispheres that might as well belong to two different planets. We've already touched on the visual differences. The near side is dominated by the dark, smooth lava plains of the Maria, which create the man in the moon. The far side is almost entirely composed of the bright, rugged, and heavily cratered highlands. But this is only a surface-level distinction. Data from lunar orbiters has revealed that the differences go all the way down to the crust. The crust on the near side is relatively thin. The crust on the far side, however, is significantly thicker. In some places, almost twice as thick as the crust on our side. Furthermore, there is a profound chemical difference. The near side is rich in a unique geological cocktail of elements that scientists have nicknamed CREEP. It's an acronym for potassium, rare earth elements, and phosphorus. These are heat-producing elements, leftovers from the last stage of the cooling of the moon's primordial magma ocean. For some reason, this CREEP material is heavily concentrated on the near side of the moon and almost entirely absent from the far side. So the puzzle is this: why? Why is the crust on one side so much thicker? Why are the volcanic Maria and heat-producing elements concentrated on the other? For decades, scientists have wrestled with this mystery, and two fascinating theories have emerged. The first is known as the two-moon theory. This idea suggests that when the giant planet Theia struck the early Earth, the collision created not one, but two moons. Our moon was the larger of the two, but it was accompanied by a smaller companion, perhaps only a third of its diameter. For tens of millions of years, these two moons shared an orbit around the Earth. Eventually, however, their orbits destabilized and they were drawn towards each other. But this wasn't a high-speed crater-forming impact. Because they were in a similar orbit, the smaller moon had a very slow, gentle collision with the larger one. Instead of blasting a crater, the smaller moon would have essentially splattered against the larger one, pancaking its material across one hemisphere. This slow-motion accretion of an entire second moon would have added a tremendous amount of rocky material, creating the thicker, mountainous crust we now see on the far side. A second, and more recent theory points not to a lost companion, but back to the intense heat of our own young planet. This is the Earthshine theory. In the aftermath of the giant impact, the moon was much, much closer to Earth than it is today, and the Earth itself was still a glowing, magma-hot world, with a surface temperature of thousands of degrees. Because the moon was already tidally locked, its near side was perpetually facing this immense furnace, while its far side faced the frigid cold of empty space. This created a massive temperature difference. The near side was constantly being cooked by the intense radiant heat from Earth, keeping it molten for much longer. The far side, however, cooled down and solidified much more quickly. As the moon's primordial magma ocean began to crystallize, elements like those in creep were the last to solidify. These elements, along with other volatiles, would have been vaporized on the hot near side and would have migrated to the cooler far side, condensing there. However, because the far side's crust had already solidified into a thick lid, this heat-producing material was trapped beneath it. The near side, with its thin crust and a concentration of creep-rich magma just below, became the perfect place for volcanism when later asteroid impacts cracked the surface. Whichever theory proves to be correct, the moon's lopsided nature is a fossilized remnant of the chaotic conditions that reigned in the early Earth-Moon system. It's a profound reminder that our two worlds have been intimately linked from the very beginning, and the story of our planet is written not just in our own rocks, but in the strange, asymmetrical geology of our constant companion. We have explored the moon as a world of profound asymmetries, a body whose very geology is shaped by its intimate, ancient relationship with the Earth. This relationship, however, is not a static one. When we look up at the moon, we see it as a symbol of permanence, an unchanging anchor in the heavens. But this too is an illusion. The cosmic dance between the Earth and the moon is dynamic, constantly evolving over eons. And the ninth great secret is that this dance is slowly leading to a separation. Our constant companion is, inch by inch, year by year, leaving us. The moon is drifting away from the Earth at a rate of about 3.8 centimeters, or 1.5 inches, per year. That's roughly the same speed at which your fingernails grow. It's a tiny, imperceptible movement on a human timescale, but over the vast expanse of geologic time, it has had profound consequences for our planet. This celestial retreat is not happening by chance. It's a direct consequence of the physics of tides and the conservation of energy within the Earth-Moon system. Here is how it works. The moon's gravity exerts a powerful pull on Earth, and its most noticeable effect is on our oceans, creating the daily rhythm of high and low tides. This pull creates two tidal bulges of water on opposite sides of the planet. Now, if the Earth didn't rotate, these bulges would lie directly on a line between the Earth and the moon. But the Earth rotates on its axis much faster, once every 24 hours, than the moon orbits around it, which takes about a month. This rapid spin drags the tidal bulges slightly ahead of the moon's position in its orbit. So, at any given moment, there is a massive bulge of ocean water slightly in front of the moon. This leading bulge of water has its own mass and therefore its own gravitational pull. It tugs on the moon, pulling it forward in its orbit. This constant forward tug acts like a gentle, continuous slingshot, giving the moon a small boost of energy. In orbital mechanics, when an object gains energy, it moves into a higher, more distant orbit. And so, pulled by the very tides it creates on our world, the moon is pushed into a wider and wider orbit, spiraling slowly away from us. This isn't just a theory. We have measured it with incredible precision. On several of the Apollo missions, Astronauts placed arrays of mirrors on the lunar surface called retroreflectors. For over 50 years, observatories on Earth have been firing powerful laser beams at these mirrors and measuring the exact time it takes for the light to travel to the moon and bounce back. This laser ranging experiment allows scientists to track the moon's distance with millimeter accuracy, confirming the 3.8 centimeter per year retreat. This slow separation has two major consequences. First, the moon appeared much larger in our ancient skies. When it first formed, it was perhaps 10 times closer than it is now, dominating the sky. As it drifts away, it will continue to appear smaller and smaller. In fact, scientists calculate that in about 600 million years, the moon will be far enough away that its apparent size in the sky will be too small to completely block out the sun. At that point, perfect total solar eclipses will no longer be possible. The second consequence is happening right here on Earth. Our days are getting longer. This is the other side of the energy exchange. As the Earth's rotation drags the tidal bulge forward, pulling on the moon's gravity pulls back on that bulge. This creates a friction that acts as a brake on our planet's spin. The Earth-Moon system must conserve angular momentum. So, the rotational momentum that the Earth loses as it slows down is transferred to the moon, pushing it into its higher orbit. 400 million years ago, a day on Earth was only 22 hours long. When the dinosaurs roamed, it was about 23 hours long. Every century, the Earth's day gets about 1.8 milliseconds longer, a tiny change that adds up over geologic time. The moon is leaving us, and it is taking a piece of our day with it. This process won't stop, but it will slow down. In the far distant future, billions of years from now, the Earth's rotation will have slowed so much that it too will become tidally locked to the moon. At that point, one day on Earth will last as long as one lunar month, and the two bodies will perpetually show the same face to each other, their cosmic dance finally reaching a stable, silent equilibrium. In our last chapter, we watched as the moon slowly drifts away from us, a process that is gradually lengthening our days. This ever-changing cosmic dance illustrates a profound truth. The Earth and moon are an interconnected system. We often think of the moon's gifts to Earth as being the gentle light it casts in the darkness and the rhythmic pull of the tides. But its most important role, the one that has allowed life to flourish on our planet, is almost completely invisible. The 10th great secret is that the moon is our planet's anchor, a gravitational stabilizer that is solely responsible for giving the Earth a predictable and stable climate. Without it, our world would be a place of unimaginable environmental chaos. To understand the moon's crucial role, we first need to understand that the Earth is not perfectly stable as it spins through space. Our planet is tilted on its axis by about 23.5 degrees. This axial tilt is the reason we have seasons. When your hemisphere is tilted towards the sun, you experience summer. When it's tilted away, you experience winter. But this tilt is not fixed. The massive gravitational pulls of the sun and the other giant planets in our solar system, particularly Jupiter, constantly tug on Earth's equatorial bulge. These forces try to pull the Earth upright, and in response to this tugging, our planet wobbles like a spinning top that is about to fall over. This slow wobble is called precession. More importantly, the angle of our planet's tilt, what scientists call its obliquity, can also change over vast periods of time. And this is where the moon becomes the hero of our story. The moon's gravitational pull on the Earth is immensely powerful, far stronger than the distant pulls of the Sun or Jupiter. Its influence on Earth's equatorial bulge is so profound that it acts as a massive counterbalance, a stabilizing anchor that prevents our planet's wobble from becoming chaotic. Think of a tightrope walker who uses a long, heavy pole to maintain their balance. The pole resists any sudden changes, keeping the walker stable. The moon is Earth's balancing pole. It effectively dampens the gravitational disturbances from the other planets, ensuring that our world doesn't tip over. Thanks to the moon's stabilizing presence, Earth's axial tilt varies only slightly, oscillating gently between about 22.1 and 24.5 degrees. This variation happens over a very long and predictable cycle of about 41,000 years, and it is one of the key drivers of the Earth's ice ages. This cycle is slow and regular enough for life to adapt. It creates a pattern of climate change, not climate chaos. So, what would a world without the moon look like? To find out, we can look to our neighbour Mars. Mars has no large moon to stabilize it. Its two tiny moons, Phobos and Deimos, are captured asteroids with almost no gravitational influence. As a result, Mars is at the mercy of the other planets. Its axial tilt is believed to vary chaotically over millions of years, from as low as 10 degrees to as high as 60 degrees. These wild swings would have caused catastrophic changes in its climate, with its ice caps potentially melting and refreezing, and its atmosphere being stripped away. Without our moon, the Earth would suffer the same fate, but even worse. Scientists' models show that our tilt could vary chaotically from nearly 0 degrees, which would eliminate seasons altogether, to as much as 85 degrees, which would mean our planet would be spinning on its side. The consequences would be apocalyptic. The poles could be pointing directly at the sun for years at a time, turning them into scorching deserts, while the equator freezes over. Any complex life that managed to evolve would be faced with environmental swings of an unimaginable and unsurvivable magnitude. The great cosmic collision that created the moon, as violent as it was a profoundly fortunate event for the future of life on Earth. It gave our planet the large, stabilizing partner it needed to maintain a climate where life could take hold, evolve, and thrive over billions of years. The moon's most precious gift is not the light it reflects in our night sky, but the stable, predictable world it has allowed us to inherit. It is our silent guardian, the anchor that keeps our world from tipping into chaos. We have come to see our moon not just as a beautiful object in the sky, but as the essential partner that stabilized our world and made life possible. Its large size relative to our planet is unique among the inner planets. Mercury and Venus have no moons at all. Mars has only 2 tiny captured asteroids. Our magnificent moon truly makes the Earth special. But has it always been our one and only celestial companion? For centuries we assumed the answer was yes. But the 11th secret reveals a sky that may have once been far more crowded. Scientists now believe it is not only possible but very likely that Earth has had other moons in its past. We have already encountered the most dramatic version of this idea when we explored the mystery of the moon's lopsided crust. The two-moon theory suggests that the same giant impact that created our main moon also formed a smaller second moon. This companion would have shared an orbit with its larger sibling for tens of millions of years. Eventually, the two were drawn together, and the smaller moon had a slow-motion collision with the far side of our moon. Instead of creating a crater, it would have splattered across the surface, adding a thick new layer of crust. This remains a leading hypothesis to explain the lunar dichotomy, and it paints a picture of an ancient Earth that had 2 moons hanging in its sky. But the story of Earth's other moons may not be confined to the deep past. It's possible that the phenomenon is still happening today, albeit on a much smaller scale. Scientists have discovered that Earth's gravity is constantly capturing small asteroids, turning them into temporary mini-moons. These objects are officially known as temporarily captured orbiters, or TCOs. Unlike our large permanent moon, these mini-moons don't settle into stable, predictable orbits. They are typically only a few feet across, the size of a boulder or a car, and they are snared by the complex gravitational interactions of the Earth-Sun-Moon system. Once captured, they follow wild, looping, chaotic paths around our planet, often being passed back and forth between the Earth's and Moon's gravitational influence. They are not permanent companions. They are more like cosmic tourists. Their visit can last for a few months, or a few years before a final gravitational nudge from the Earth or Moon flings them back out into the solar system to continue their journey around the Sun. This is not just a theory. We have now observed these fleeting visitors directly. In 2006, astronomers discovered an object named 2006 RH-120. It was a small asteroid, about the size of a car, that had been captured by Earth's gravity. It made several looping orbits of our planet for about a year before it was ejected in 2007, becoming the first confirmed example of a temporary mini-moon. More recently, in 2020, another car-sized object, 2020 CD3, was discovered. Analysis of its trajectory showed that it had been a temporary moon of Earth for about 3 years before it, too drifted away. Computer simulations suggest that at any given time, there is a high probability that at least one of these small, 1-meter-sized asteroids is in a temporary orbit around Earth. They are just incredibly faint, fast-moving, and difficult to detect with our current technology, so we have only just begun to spot them. So, the history of Earth's companions is likely far richer than we ever imagined. Our sky may have once been graced by a second, permanent moon, a companion that was ultimately sacrificed to build the world we see today. And our planet is continuously, if temporarily, accompanied by a succession of tiny, captured asteroids, fleeting mini-moons that come and go over the millennia. Our moon is not our only companion, but it is our primary and permanent one, the only one large enough and close enough to fundamentally shape our world. But the sky above is not as empty as it seems. We have one great, steadfast moon, and an unknown number of tiny, ghostly ones that have shared and continue to share our long journey through the cosmos. We've explored the long, slow dance of the Earth and Moon, a relationship of immense gravitational power that has stabilized our climate and is gradually pushing our companion away. The most visible evidence of this power is, of course, the ocean tides. Twice a day, the Moon's gravity lifts trillions of tons of water, creating a rhythmic rise and fall of the sea that has shaped coastlines and human history. We see this immense force at work on the liquid part of our planet. We stand on what we call solid ground for a reason. We feel it is a firm and stable foundation, immune to this celestial tug of war. But what if that, too, is just another illusion born of human perspective? What if the ground beneath our feet is not as solid as it seems? The 12th great secret is that the Moon's gravity is so powerful, it doesn't just affect our oceans. It creates tides in the very rock of the Earth itself. This phenomenon is known as the solid Earth tide, or land tide. The mechanism behind it is exactly the same as the one that drives our ocean tides. The Moon's gravitational pull is slightly stronger on the side of the Earth facing it, and slightly weaker on the side opposite. This differential pull effectively stretches our entire planet into a slightly oblong shape, a prolate spheroid, with two bulges on opposite sides. While water is fluid and can move freely to create these bulges, the rock of the Earth's crust and mantle is not perfectly rigid. It has a degree of elasticity, like very hard rubber. Under the immense and constant strain of the Moon's gravity, the solid body of our planet deforms and bulges in response. The scale of this deformation is astonishing. As you go about your day, the solid surface of the Earth beneath you rises and falls by a significant amount. At the equator, this daily vertical movement can be as much as 50 centimeters, or about 20 inches. Twice a day, the continent you are standing on is gently lifted up by nearly 2 feet, and then just as gently set back down again. This raises an obvious question. If the ground is rising and falling by such a large amount, why don't we feel it? The reason is that the deformation happens incredibly smoothly and over a massive planetary scale. The entire landscape rises and falls together. The buildings, the roads, the trees, and you are all moving in perfect unison with the ground. Since there is no stationary local reference point, the motion is completely imperceptible to our senses. It's like being on a continent-sized elevator that moves so smoothly you are entirely unaware of the journey. But just because we don't feel it doesn't mean it isn't happening. This isn't just a theoretical concept. It has very real measurable effects that modern science and technology must account for. For example, high-precision instruments like the Large Hadron Collider, a particle accelerator built in a 17-mile-long underground ring, are affected by land tides. The slight warping of the Earth's crust is significant enough that engineers must constantly adjust the particle beam to compensate for the ground itself moving. Similarly, the Global Positioning System, or GPS, would not work accurately without correcting for the solid Earth tide. GPS satellites rely on incredibly precise timing and location data. As the ground stations on Earth rise and fall by nearly 2 feet, their position in space changes. If these changes weren't factored into the GPS calculations, the location data sent to your phone or car could be off by a significant amount. The land tide also contributes stress to the Earth's tectonic plates and can, in some cases, be the final trigger for earthquakes or volcanic eruptions in highly sensitive fault zones. So, the term solid ground is a relative one. Our planet is not a rigid, unchanging rock. It is a dynamic, elastic body, constantly being kneaded and stretched by its powerful lunar companion. The moon's influence is not confined to our oceans. It is imprinted on the very fabric of our planet. A silent, powerful force that warps the world beneath our feet every single day. We've seen how the moon's gravity physically deforms our own planet. But how do we study the interior of the moon itself? We can't drill tens or hundreds of miles into its crust. The key is a science called seismology. By studying how shockwaves travel through a planet's interior, scientists can deduce what it's made of, whether it's solid or liquid, and how its layers are structured. To do this, you need a source for the shockwaves, a quake, and an instrument to listen. During the Apollo missions, scientists decided not to wait for natural moonquakes. They decided to create their own. And when they did, they made one of the most bizarre and revealing discoveries in lunar history. They found that the moon rings like a bell. This incredible finding came from the active seismic experiments conducted during the Apollo era. The plan was simple but brilliant. Create a series of artificial impacts on the moon with objects of a known mass and velocity, and then listen to the resulting shockwaves with the network of seismometers the astronauts had placed on the surface. The impactors were the spent SIVB third stages of the giant Saturn V rockets, and after the astronauts had returned to orbit, the discarded ascent stages of the lunar modules. These objects, weighing several tons, were deliberately sent on a collision course with the moon, striking it with the force of many tons of TNT. Scientists on Earth watched the data stream in from the seismometers, expecting to see a signal similar to a small earthquake on our own planet. On Earth, a seismic event is a short, sharp affair. The shockwaves travel for a few minutes before they are quickly absorbed and dampened by the ground. They expected the moon to be similar. What they saw instead was astonishing. The initial shock of the impact was recorded, but then the signal didn't die down. It grew and swelled, and the entire moon began to vibrate, and it didn't stop. The seismic signals from the impact continued for an incredibly long time. In the case of the Apollo 12 impact, the moon reverberated for nearly an hour. For the much larger impact of the Apollo 13 SIVB stage, it vibrated for over 3 hours. The scientists were stunned. As one of them famously described it, the moon was ringing like a bell. So, why does the moon ring? The answer reveals the fundamental difference between the interior of the Earth and the moon. The Earth's interior is a relatively hot, dynamic and wet place. It has a molten outer core, a partially molten mantle, and a crust saturated with water. These materials, especially liquids like water and magma, are excellent at damping or absorbing seismic energy. When an earthquake's shockwaves travel through these materials, their energy is quickly dissipated. It's like hitting a bell that's been filled with mud. You get a dull thud, and the vibrations die almost instantly. The moon's interior, by contrast, is a very different environment. It is thought to be much colder, more rigid, and almost completely bone-dry. There is very little water or molten rock to absorb shockwaves. The moon's crust and mantle are composed of fractured but solid rock, which is an incredibly efficient transmitter of seismic energy. When the shockwaves from an impact enter this material, they don't get absorbed. They just keep traveling, bouncing and echoing off the different layers deep inside the moon for a very long time, before finally fading away. It's the difference between striking a solid block of steel, which will ring for a long time, and striking a block of wet sponge. The moon is like the block of steel. This single startling discovery told us more about the moon's interior than years of observation ever could. It confirmed that the moon is not a miniature Earth. It is a cold, dry and incredibly rigid world. It's not geologically dead, as we know from moonquakes, but it is largely solid. By striking the moon and listening to its response, the Apollo scientists allowed us to hear the very nature of its structure. The sound of the moon ringing like a bell is the sound of a world without water, a world preserved in a rigid, ancient state, providing a profound and resounding contrast to our own dynamic, fluid planet. Our exploration of the moon has revealed it to be a dynamic world, a body that trembles with quakes and whose gravity reshapes our own planet. As humanity prepares to return to the moon, not just for fleeting visits, but to establish a long-term presence, we are faced with a new set of challenges that are less about geology and more about logistics. This brings us to a question that sounds like the beginning of a riddle. What time is it on the moon? For decades, the only answer was, whatever time it is in Houston, Texas. But as we enter a new era of lunar exploration, that is no longer good enough. The 14th great secret is that the moon is on the verge of getting its very own official time zone. During the Apollo program, timekeeping was simple. There was only ever one mission on the surface at a time, and all operations were synchronized to Coordinated Universal Time, or UTC, as managed by Mission Control in Houston. The astronauts' watches were set to Houston time, and the entire mission ran on a single Earth-based clock. But the future of lunar exploration will be far more complex. Within the next decade, we envision a bustling lunar environment. There will be orbiting space stations like the Lunar Gateway, multiple landers and rovers on the surface from different national space agencies like NASA, ESA, and China, as well as private companies. For all of these missions to communicate, navigate, and coordinate activities safely and effectively, they need to be synchronized to a single, agreed-upon clock. Relying on a patchwork of different Earth-based time zones would be a logistical nightmare, leading to confusion and potentially catastrophic errors. A unified, independent timekeeping system for the moon is now a practical necessity. However, establishing a lunar time zone is not as simple as just picking a starting point. It presents a unique set of scientific and political challenges. The most mind-bending of these comes from Albert Einstein's theory of relativity. His theory tells us that time is not absolute. It is relative and can be affected by gravity. Because the moon has a much weaker gravitational field than the Earth, time itself actually passes slightly faster there. A clock on the lunar surface would run ahead of a clock on Earth by about 58.7 microseconds every single day. This might sound like an insignificant amount, but for modern space navigation, which relies on incredibly precise timing, it's a colossal difference. If this time dilation were not accounted for, a spacecraft trying to perform an automated landing on the moon could miscalculate its position by a large margin, and communication links between different missions could fail to synchronize. The lunar timekeeping system must therefore be defined independently of Earth's time, with a clear formula for converting between the two. Then there is the authority problem. On Earth, Coordinated Universal Time is managed by international agreements. Who gets to set the clock for the moon? To solve this, space agencies around the world, led by the European Space Agency and NASA, are now working together to establish a framework called Coordinated Lunar Time, or LTC. The goal is to create a common timekeeping system that all future missions, regardless of their country of origin, can use. The creation of a lunar time zone is more than just a technical solution to a logistical problem. It is a profound symbol of humanity's changing relationship with the moon. It marks the transition from seeing the moon as a distant destination to be visited, to seeing it as a new domain of sustained human activity, a place where we will live and work. The question, what time is it on the moon, is no longer a philosophical riddle. It is a practical engineering problem that we are on the verge of solving. The moon is about to get its own clock. When we think of the moon, we imagine a landscape of pristine, untouched desolation, a place of majestic silence, covered in a fine grey dust that has lain undisturbed for billions of years, marked only by the craters of cosmic impacts. This image of a pure, unsullied world is a powerful one. But since July 20th, 1969, it has no longer been true. For over 50 years, humanity has been leaving its mark on the lunar surface. The 15th great secret is that the moon is not pristine. It is the site of humanity's first off-world archaeological sites, a celestial museum containing our scientific tools, our discarded machinery, our symbols of peace, our personal mementos, and yes, our garbage. In total, humanity has left behind nearly 200 tons of material on the moon. This collection of artifacts tells the story of our first steps into the cosmos. A large portion of this mass consists of scientific instruments. The Apollo missions deployed complex experimental packages known as ALSEPs, which included instruments like the seismometers that detected moonquakes and the laser retroreflectors we still use today to measure the moon's distance. These were designed to be left behind, continuing to gather data long after the astronauts had gone. The heaviest category of objects is discarded hardware. This includes the descent stages of the 6 Apollo lunar modules, which served as the launch pads for the astronauts' return journey and now stand as permanent monuments at each landing site. It includes the 3 electric lunar roving vehicles, the moon buggies, parked and left behind by the last 3 Apollo crews. It also includes the spent rocket boosters and numerous robotic probes from various nations that were intentionally crashed into the surface. But beyond the science and machinery, there are the deeply human items. There are the 6 American flags, whose colors have likely been bleached completely white by decades of unfiltered solar radiation. There are the plaques on the landers' legs, bearing messages of peace for any civilization that might one day find them. And there are incredibly personal mementos. Apollo 16. Astronaut Charles Duke left a small, plastic-encased photograph of his family on the ground. The crew of Apollo 15 left behind the fallen astronaut, a small aluminum sculpture and a plaque, bearing the names of the 14 American astronauts and Soviet cosmonauts known at the time to have died in the pursuit of space exploration. Then, there are the more mundane and bizarre items. Alan Shepard, an avid golfer, famously hit 2 golf balls on the surface during the Apollo 14 mission. They are still lying there in the dust. And among the most unusual items left behind are 96 bags containing human waste, urine, feces, and vomit. These were jettisoned from the landers to save precious weight for the journey back to Earth. Today, scientists are deeply interested in studying these bags to see if any microorganisms could have survived the extreme conditions on the lunar surface for half a century. And finally, there is art. In 1969, an engineer secretly attached a tiny ceramic tile, no bigger than a thumbnail, to the leg of the Apollo 12 lunar lander. It bears microscopic drawings from 6 prominent artists of the era, including Andy Warhol. Known as the Moon Museum, it is arguably the first piece of art ever installed on another world. So, while we may call some of it garbage, these hundreds of objects are now considered priceless historical artifacts. The Apollo landing sites are, in effect, the first human ruins on another planet. Future explorers will likely be required to treat them with the same care and reverence we afford ancient archaeological sites on Earth. They are a strange and eclectic museum of humanity, a mix of high technology and mundane waste, of profound symbolism and personal sentiment. They are our legacy, a testament to that brief golden age when we first left our world and walked upon another. We have journeyed deep inside the moon, learning of its quakes and its curious, ringing structure. We've seen how its gravity shapes our world, and how our world may have shaped its lopsided crust. Now, we return to the surface and to one of the most personal and unexpected discoveries made by the humans who walked there. We can imagine what the moon looks like, but what does it smell like? The question itself seems absurd. Space is a near-perfect vacuum. There is nothing for the nose to detect. An astronaut, sealed inside a helmet and suit, should not be able to smell anything at all, and yet, when the Apollo astronauts returned to the safety of their lunar module after walking on the moon, they were greeted by a powerful, distinct, and completely unforeseen aroma. The 16th great secret is that the moon itself has a smell, and it's the sharp, acrid scent of a recent explosion. The scene was the same on every mission. After their moonwalk, the astronauts would climb back into the cramped lunar module and repressurize the cabin. Inevitably, the fine grey dust that had coated their boots, gloves, and equipment became airborne inside the small spacecraft. As they removed their helmets, the smell hit them, and it was unmistakable. Harrison Schmitt of Apollo 17, the only trained geologist to ever walk on the moon, was perhaps the most articulate. He declared that the dust smelled exactly like spent gunpowder. He wasn't alone. Other astronauts described it in similar terms. Apollo 11's Buzz Aldrin noted a smell like burnt charcoal, or the ash you would find in a fireplace. Others called it metallic, or described an ozonic sharpness, like the air after a lightning strike. It was a consistent, strong, and pungent odor, the first and only scent of another world ever experienced by humans. So, what could possibly cause this? The dust itself has no smell in a vacuum. The aroma was the result of a chemical reaction that could only happen when the ancient dust met fresh, breathable air for the first time. The leading theory points to a feature of the lunar dust known as dangling bonds. For billions of years, the regolith has existed in an environment with no free oxygen and no water. Unlike rocks on Earth, whose surfaces have been pacified by constant exposure to our atmosphere, the atoms on the surface of each lunar dust grain are highly reactive and chemically unsatisfied. They have unfulfilled chemical bonds, just waiting for something to react with. When this activated dust was brought inside the lunar module, it was suddenly exposed to the oxygen-rich, humid air of the cabin. It reacted instantly and aggressively with the oxygen and water molecules. This process, a form of incredibly rapid oxidation, is what created the sharp, burnt smell. The astronauts were not smelling the dust itself, but the chemical aftermath of its first contact with an Earth-like atmosphere. They were, in a very real sense, smelling the scent of a rock that had not touched air in over 4 billion years. Another contributing factor could be the solar wind. As we've learned, the lunar surface is constantly being bombarded by charged particles from the sun. The dust is saturated with these high-energy ions, like hydrogen and helium. It's possible that when these implanted ions mixed with the oxygen and moisture inside the cabin, they too underwent chemical reactions that produced a distinct odor. This discovery also came with a caution. The smell was accompanied by a physical reaction. Several of the astronauts reported a form of lunar hay fever, with watery eyes, sneezing, and a sore throat. The dust was not just chemically reactive, but also, as we learned earlier, incredibly sharp and abrasive. The smell of the moon is a powerful sensory postcard from another world, but it's also a warning. It is the scent of a substance that is alien, reactive, and potentially hazardous. A pungent reminder of the stark and beautiful otherness of the lunar landscape. Perhaps no image from the Apollo program is more iconic than that of an American flag being planted on the lunar surface. It is a powerful symbol of human achievement, a testament to the culmination of a decade of intense effort, broadcast to hundreds of millions of people back on a wrapped Earth. A total of 6 flags were planted on the moon by the crews of Apollo 11, 12, 14, 15, 16, and 17. In our minds, we imagine them still standing there. A vibrant splash of red, white, and blue against the grey. Desolate landscape. But that image, so deeply ingrained in our collective memory, is frozen in the past. After more than half a century of standing on the moon, exposed to one of the most hostile environments imaginable, those iconic flags have been irrevocably changed. The 17th great secret is that the vibrant symbols of national pride planted on the moon are now likely ghostly white. To understand why, we must appreciate the sheer brutality of the lunar environment. On Earth, our atmosphere and magnetic field act as a protective shield, absorbing the vast majority of the sun's harmful radiation. The moon has no such protection. For more than 50 years, the Apollo flags have been subjected to a constant, relentless bombardment of unfiltered solar radiation. The primary culprit in their decay is the sun's powerful ultraviolet, or UV. Light UV radiation is a high-energy form of light that is incredibly effective at breaking down chemical bonds. The colors in the flag's dye are created by specific molecules that absorb some wavelengths of light and reflect others. The intense UV radiation on the moon would have systematically shattered these dye molecules, causing the colors to fade and eventually disappear entirely. There is simply no earthly dye that could withstand 5 decades of that kind of punishment. But UV radiation is only part of the assault. The flags have also been exposed to the full force of the solar wind, cosmic rays, and micrometeorite impacts, all of which contribute to the physical and chemical breakdown of the fabric. Furthermore, the flags have had to endure the moon's extreme temperature swings. During the 2-week-long lunar day, temperatures on the surface can soar to 260 degrees Fahrenheit, or 120 degrees Celsius. Then, During the 2-week night, they plummet to a cryogenic minus 280 degrees Fahrenheit, or minus 173 Celsius. This constant, brutal cycle of extreme heating and cooling would cause the nylon fabric of the flags to become incredibly brittle and fragile over time. So, what is the current state of the flags? We actually have a very good idea thanks to NASA's Lunar Reconnaissance Orbiter, or LRO. This spacecraft has been orbiting the Moon since 2009, taking incredibly high-resolution photographs of the surface. LRO has successfully imaged the Apollo landing sites and has confirmed that the flagpoles are still standing and casting shadows at the sites for Apollo 12, 16, and 17. The flags for Apollo 14 and 15 are also presumed to be standing. The only exception is the very first flag, planted by Apollo 11 Buzz. Aldrin reported seeing it get knocked over by the powerful exhaust from the ascent engine as he and Neil Armstrong lifted off from the surface. While LRO can see the shadows of the poles, it cannot resolve the colors on the flags themselves. The scientific consensus, however, is clear. Based on our understanding of how materials degrade in the harsh lunar environment, the red and blue dyes would have been completely bleached away. The flags that remain standing are now colorless, ghostly white sheets of nylon. They are also likely in a state of advanced decay, brittle and possibly fragmenting from the thermal stress. The fading of the flags is not a symbol of a faded achievement. Rather, it is a powerful and poignant testament to the harshness of the cosmos. They are no longer symbols of a single nation, but have transformed into something more universal. Ghostly monuments to the first human presence on another world, slowly being erased by the very environment we sought to explore. Our journey across the Moon has revealed a landscape that is both a museum and a monument. We've seen the flags, tools, and personal mementos left behind by the Apollo astronauts, artifacts that mark our first tentative steps into the cosmos. These objects form a human story written in the lunar dust. But there is one final, and perhaps most profound, human story etched upon the Moon. A story of a dream fulfilled in the most extraordinary way. We have left our footprints in our machines, but has a human being ever been laid to rest on that distant, silent world? It sounds like a concept from the pages of science fiction, and yet the answer is yes. The 18th great secret is the story of the one person whose final resting place is another world. His name was Dr. Eugene Shoemaker, but to everyone in the world of planetary science, he was simply Gene. He was a legendary figure, widely considered to be the father of a new field of science called astrogeology. In the 1950s and 60s, it was Gene Shoemaker who pioneered the study of impact craters, proving that many of Earth's most famous craters, like the Barringer crater in Arizona, were formed by asteroid impacts and not by volcanic activity, as was previously believed. He effectively wrote the book on how to read the violent history of a planet by studying its scars. His expertise was so profound that when NASA began planning to send humans to the Moon, they turned to him. Gene Shoemaker was instrumental in the Apollo program. He helped select the geologically interesting landing sites and personally trained the Apollo astronauts. He taught these test pilots and engineers how to think like geologists, instructing them on what to look for, how to describe the landscape, and which rocks would be the most valuable to bring back to Earth. He gave them the scientific eyes they needed to explore another world. But throughout it all, Gene harbored a deep personal dream: to go to the Moon himself. He was an official candidate for the astronaut corps, but he was ultimately disqualified from flight for medical reasons. He suffered from Addison's disease. Watching the men he trained walk on the lunar surface while he was confined to mission control was, in his own words, the biggest disappointment of my life. Gene Shoemaker never stopped exploring, however. He went on to have a brilliant career, culminating in the co-discovery of the famous comet Shoemaker-Levy 9, which he watched collide spectacularly with the planet Jupiter. Tragically, in 1997, while on a meteorite crater expedition in the Australian outback, he was killed in a car accident. In the wake of his death, a former student and close colleague, Carolyn Porco, was looking for a fitting tribute. She knew of his unfulfilled dream and came up with a bold and beautiful idea. If Gene Shoemaker could not walk on the moon in life, perhaps he could go there in death. She proposed that NASA send a portion of his cremated remains to the moon. NASA agreed. An ounce of his ashes was sealed in a small polycarbonate capsule. The capsule was wrapped in a piece of brass foil, inscribed with a laser-etched image of the Hale-Bopp comet, a diagram of the Barringer crater, and a passage from William Shakespeare's Romeo and Juliet. And, when he shall die, take him and cut him out in little stars, and he will make the face of heaven so fine that all the world will be in love with night. This tiny memorial was attached to NASA's Lunar Prospector spacecraft, which launched in January of 1998 on a mission to orbit and map the moon. For a year and a half, Gene Shoemaker orbited the world he had dedicated his life to studying. Then, on July 31st, 1999, at the end of its mission, the Lunar Prospector was deliberately sent on a final plunging trajectory. It crashed as planned into a permanently shadowed crater near the moon's south pole. With that final, silent impact, Gene Shoemaker became the first and, to this day, the only human being whose remains have been laid to rest on a celestial body other than Earth. The man who taught humanity how to read the story written in the moon's rocks had finally, and forever, become a part of that story himself. Our lunar journey has shown us a world shaped by immense forces, from the gravity that molds its body to the impacts that ring it like a bell. On Earth, one of the most powerful forces is erosion. The relentless flow of water can, over millions of years, carve features of breathtaking scale, with the most famous example being the Grand Canyon. It is a testament to the power of a river, but the moon is a world with no rivers, no rain, and no wind. It is a world where the forces of erosion are almost non-existent, and yet the moon has canyons of its own, vast winding channels that, in some ways, rival the scale of our own terrestrial wonders. The 19th great secret is that the moon is home to a spectacular canyon, carved not by ancient rivers of water, but by ancient rivers of fire. These features are known to scientists as lunar rilles, from the German word for groove. They are long, channel-like depressions that snake across the lunar surface, and they come in several varieties. Some are straight, believed to be sections of crust that have dropped between parallel faults. But the most spectacular and river-like are the sinuous rilles, and of all the sinuous rilles, one stands out as the most magnificent: Vallis Schroetteri, or Schroeter's Valley, located on the Aristarchus Plateau, one of the most geologically diverse regions on the moon. Vallis Schroetteri is often called the moon's Grand Canyon. It is a truly colossal feature. The rill begins at a crater known as the Cobra's Head, and then winds its way across the lunar surface for over 100 miles, or 160 kilometers. At its widest point, it is over 6 miles, or 10 kilometers across, and it sinks to a depth of nearly a full kilometer, or about half a mile. While the Grand Canyon is significantly deeper and longer, the sheer scale of Vallis Schroetteri, carved into a world without water, is a breathtaking geological puzzle. So how could such a feature form on a dry, airless world? The answer, as with so many lunar mysteries, is volcanism. The leading theory is that Vallis Schroetteri is a collapsed lava tube, or a channel carved by an immense river of molten rock. Billions of years ago, the Aristarchus Plateau was the site of an enormous and sustained volcanic eruption. This eruption didn't build a mountain. Instead, it poured a massive, fast-flowing river of incredibly hot and fluid lava across the lunar landscape. This river of fire may have been so hot and energetic that it carved its own channel through thermal erosion, melting and vaporizing the rock beneath it as it flowed. Alternatively, and perhaps more likely, is the lava tube theory. As this massive river of lava flowed, its top surface, exposed to the cold of space, would have cooled and solidified, forming a solid roof over the still-flowing molten rock beneath. This created an insulated underground tunnel known as a lava tube. Because of the moon's low gravity, these lava tubes could grow to be enormous, far larger than any on Earth. After the volcanic eruption finally ceased and the last of the lava drained away, a massive hollow cavern, hundreds of miles long, would have been left behind. Then, over billions of years, the roof of this massive tube, weakened by moonquakes and meteorite impacts, collapsed in sections, revealing the vast, winding canyon-like valley that we see today. The Cobra's Head at the start of the rill is believed to be the primary volcanic vent where this colossal eruption began. So, the Moon's grandest canyon is not a memorial to a long-lost river of water, but to an ancient, unimaginably large river of fire. Valles Schroeterei is a silent, spectacular testament to a time when the Moon was a far more violent and volcanically active world. Today, these features are more than just a geological curiosity. Scientists believe that sections of these vast lava tubes that have not collapsed could still be intact, offering natural, pre-made caverns. These tunnels could be prime locations for future human habitats, as their thick rock ceilings would provide excellent protection from the hazards of radiation and meteorite impacts. The Moon's Great Canyons are not just a window into its fiery past, but a potential gateway to our future there. We tend to think of the Moon as a symbol of constancy. Its phases are predictable, its features are unchanging, and its light is a steady, reliable presence in our night sky. It is a serene and silent world. But what if that silence is occasionally broken by a sudden, inexplicable flash of light? What if the Moon's calm grey face sometimes glows or even changes colour right before our very eyes? The 20th great secret is that our serene Moon is a place of mysterious and fleeting lights. For centuries, credible observers have reported seeing strange, brief flashes and glows on the lunar surface, a baffling phenomenon known to science as transient lunar phenomena, or TLP. These are not the fevered reports of conspiracy theorists. The history of TLP sightings is long and filled with credible names. In 1178, monks in Canterbury, England, recorded seeing the upper horn of the new moon split in two and spew forth fire, hot coals and sparks. In 1787, the renowned astronomer Sir William Herschel, discoverer of the planet Uranus, reported observing what he believed to be 3 volcanic eruptions on the moon. And in the modern era, even Apollo-era astronauts reported seeing inexplicable bright glows in certain craters. For a long time, the scientific community was deeply skeptical, often dismissing these reports as observational errors, tricks of the Earth's atmosphere, or simply stray satellites passing in front of the moon. But the reports, from both amateur and professional astronomers, were too numerous and too consistent to ignore. With the advent of modern telescopes, video recording, and dedicated monitoring programs, we now know that transient lunar phenomena are real. The moon is indeed an active place, but the cause of its flashes is not one single thing, but a collection of fascinating processes. One of the most common and now confirmed causes is meteorite impacts. Because the moon has no atmosphere to act as a shield, it is constantly being struck by space debris. When even a small pebble-sized meteoroid hits the surface at tens of thousands of miles per hour, its immense kinetic energy is instantly converted into a brilliant flash of heat and light. In recent years, automated telescope networks on Earth have been set up to specifically watch for these events, and they now regularly record dozens of these impact flashes every year. Many historical TLP sightings were almost certainly this exact phenomenon. Another leading explanation is outgassing. As we've learned, the moon is not entirely geologically dead. Pockets of gas, such as radon, which is a product of radioactive decay, are thought to be trapped beneath the lunar surface. The gravitational stress from the Earth's tidal pull can cause the ground to fracture, allowing these gases to suddenly escape in a brief, powerful puff. This escaping gas could stir up the fine electrostatically charged lunar dust, creating a temporary cloud that would reflect sunlight differently, appearing to a distant observer as a sudden hazy or bright spot that lasts for a few minutes before settling down. A third possibility involves electrostatic discharges. In the harsh, airless environment of the moon, the surface dust can build up a significant electrical charge from the constant stream of the solar wind. It's possible that this accumulated charge could lead to small electrical discharges between different regions of dust, creating something like a tiny lightning strike in the regolith, which would be visible as a faint, instantaneous flash. So, the steady face of the moon is a facade. It is a world that still flashes and glows as it is struck by debris from space and as it breathes out ancient gases from its deep interior. While we can now confidently explain many of these flashes as impacts, other events, especially those involving color changes or hazy glows, remain a compelling puzzle. These fleeting lights are a beautiful and visual reminder of the active, ongoing processes that continue to shape our nearest celestial neighbor, proving that even the most familiar face in our sky can still hold a startling secret. When we think about temperature in our solar system, we imagine a simple, predictable gradient. Planets close to the Sun, like Mercury, are scorching hot. Planets far from the Sun, like Neptune and the dwarf planet Pluto, are unimaginably cold. So, where would you guess we have found the absolute coldest naturally occurring temperatures? On the frozen plains of Pluto? In the dark atmosphere of a distant gas giant? What if I told you that some of the coldest spots ever recorded are in our own cosmic backyard, on a world that is the exact same distance from the Sun as we are? The 21st great secret is a stunning paradox. The sun-baked moon is also home to the most extreme and profound cold in the entire solar system. This incredible phenomenon is found at the lunar poles. The key to understanding it lies in the moon's axial tilt. The Earth is tilted on its axis by a significant 23.5 degrees. This is why we have seasons, and it ensures that over the course of a year, the sun's rays shine directly on almost every part of our planet, from the Tropic of Cancer to the Tropic of Capricorn. The moon, however, is almost perfectly upright. Its axial tilt is a tiny 1.5 degrees. This seemingly small difference has a colossal consequence. At the moon's north and south poles, the sun's light always comes in at an incredibly low, grazing angle, barely skimming the horizon. In this unique environment, there are deep craters whose floors are angled in such a way that the sun's rays have never, ever reached the bottom. These areas are known as permanently shadowed regions, or PSRs. They have been in a state of continuous, absolute darkness for billions of years. In a place that receives no direct heat from the sun, and with no atmosphere to circulate warmth, the temperature plummets to lows that are difficult to comprehend. Using instruments aboard its Lunar Reconnaissance Orbiter, NASA has measured the temperatures inside these polar craters. They are as low as -410 degrees Fahrenheit, or -248 degrees Celsius. That is only about 25 degrees Celsius above absolute zero, the theoretical point at which all atomic motion ceases. To give that some context, this is significantly colder than the average surface temperature of Pluto. The moon, our close and familiar neighbor, harbors a cold that is more extreme than the most distant, frozen worlds of our solar system. This profound cold has an even more profound implication. These permanently shadowed regions act as the ultimate cold traps. Over billions of years, the moon has been bombarded by comets and asteroids, which are rich in water ice and other frozen compounds. When these objects strike the moon, the water molecules are vaporized and scattered across the surface. Most of these molecules are quickly broken down by sunlight or escape into space. Water molecules entering lunar polar cold traps freeze permanently. These craters have accumulated vast deposits of water ice and other frozen volatiles. This discovery transforms our lunar return plans. The seemingly dry moon paradoxically holds water, a vital resource for space exploration. This frozen water can be harvested for drinking, breathable oxygen, and rocket fuel, making the moon's darkest, coldest regions key to humanity's future there. We have journeyed across the moon's surface, uncovering its secrets from its strange smell to its mysterious flashes of light. We have learned that it is a world of incredible hostility. With no atmosphere, its surface is exposed to a constant barrage of deadly solar and cosmic radiation, a relentless rain of micrometeorite impacts, and temperature swings of hundreds of degrees. As humanity plans its return to the moon to stay, The greatest single challenge is how to survive in such a place. Building surface habitats that can withstand these hazards is a monumental engineering task. But what if the moon has already provided the solution? The 22nd great secret is that the moon has natural, pre-made shelters in the form of deep, dark pits, or skylights, that lead into vast, protected underground caverns. We've already encountered the moon's violent volcanic past when we explored the great rills, or canyons, carved by ancient rivers of fire. For decades, scientists have theorized that many of these rills were once massive underground lava tubes whose roofs had since collapsed. They speculated that some of these enormous tunnels might still be intact, hidden just beneath the surface. The problem was finding an entrance. That all changed in 2009. While studying images from Japan's Kaguya lunar orbiter, scientists spotted something they had never seen before. A strange, deep, almost perfectly circular pit about 200 feet across that punched straight down into the lunar surface. It didn't look like an impact crater. It looked like a hole. Since then, NASA's Lunar Reconnaissance Orbiter, with its powerful cameras, has found hundreds more of these features all across the moon. These are the lunar skylights. They are now understood to be sections where the roof of a massive intact lava tube has collapsed, likely after being weakened by a small meteorite impact. They are, quite literally, skylights into a hidden underground world. The images are tantalizing. Many of the pits show overhanging ledges and shadows that reveal they open up into a void that is much, much wider than the entrance itself. The discovery of these skylights has completely transformed our vision for lunar colonization. These are not just caves, they are entrances to potentially colossal subterranean caverns. Because of the moon's low gravity, its lava tubes are thought to be enormous, far larger than any on Earth. Some could be a mile or more wide, big enough to comfortably house entire cities, all shielded by a thick, natural roof of solid rock. The advantages of building a human habitat inside one of these lava tubes are immense. First and foremost is protection from radiation. The thick rock ceiling would provide near-perfect shielding from the deadly solar particle events and galactic cosmic rays that plague the surface. Secondly, it would offer complete protection from the constant rain of micrometeorites. But perhaps most importantly, it would provide a stable temperature. While the lunar surface swings from a scorching 260 degrees Fahrenheit to a cryogenic -280, the temperature inside a lava tube is believed to be a stable, constant, and relatively mild -4 degrees Fahrenheit, or -20 degrees Celsius. This would drastically reduce the energy needed for heating and cooling, making a long-term settlement far more viable. The moon's violent, fiery past has, by a remarkable stroke of luck, created the perfect shelters for its human future. These dark pits are not just geological curiosities. They are doorways to a new era of exploration. Instead of building on the dangerous surface, our first lunar colonists may live and work beneath it, in the grand, silent halls of the moon's ancient volcanic tunnels. The Apollo landing sites are precious historical monuments, frozen moments in time that mark humanity's first steps onto another world. But these 6 small sites are just a tiny fraction of the human presence that now dots the lunar landscape. Over the past 6 decades, as we have reached out to explore our nearest neighbor, the moon has taken on another, unspoken role. It has become a celestial graveyard, the final resting place for dozens of spacecraft from nations all around the world. The 23rd great secret is that the moon is a silent, accidental museum, a repository of our cosmic ambitions, our stunning triumphs, and our heartbreaking failures. Since the dawn of the space age, well over 70 different spacecraft and their components have impacted the moon. Many of these were sent there by design. The very first human-made object to touch another world was the Soviet Union's Luna 2 probe in 1959, which was a simple impactor. It was followed in the early 1960s by NASA's Ranger series of spacecraft, whose entire mission was to crash, taking as many close-up pictures as possible during their final, one-way journey to the surface. This practice of intentional crashing continues today. Many modern lunar orbiters, after they have exhausted their fuel and completed their missions, are commanded to perform a final deorbit burn and crash into the surface. This is done to prevent them from becoming uncontrolled space debris that could endanger future missions. This was the fate of NASA's Lunar Prospector, which carried the ashes of Gene Shoemaker to his final resting place, and the twin Grail spacecraft, which created 2 new craters after completing their mission to map the moon's gravity. The powerful SIVB rocket boosters from the Apollo missions were also intentionally crashed to create the artificial moonquakes we discussed earlier. But not all of the moon's artificial craters are the result of planned events. The surface is also littered with the wreckage of missions that failed. Landing on the moon is incredibly difficult, and its surface holds the scars of many failed attempts. In recent years, a new wave of private and national missions has been met with this harsh reality. The Israeli Bereshit lander in 2019, the Japanese Hakuto R lander in 2023, and Russia's Luna 25 probe, also in 2023, all tragically crashed during their final landing maneuvers. These wrecks are not just failures. They are hard-won lessons, somber reminders of the immense challenges of space exploration. When you add to this list the discarded descent stages of the 6 Apollo landers and other miscellaneous hardware, the moon is revealed to be far from pristine. It is a world dotted with the scattered remnants of our technology. This celestial graveyard serves as a unique archaeological record of the space age. It charts our entire history of lunar exploration, from the crude impactors of the 1950s to the sophisticated robotic landers of today. The moon is no longer a purely natural body. It is an artifact of human history. Its silent surface holding the story of our relentless drive to reach beyond our home world. A story told in both our proudest monuments and our shattered machines. Throughout our journey, we have explored the moon's unique geology, its violent history, and its intimate relationship with Earth. We call it the moon, our one and only natural satellite. The definitions we learn in school seem simple and absolute. Planets orbit the sun, and moons orbit planets. This celestial hierarchy seems clear-cut. But what if our very own moon blurs that line? What if, by some reasonable definitions, it has more in common with a planet than it does with a simple moon? The 24th great secret is that our moon is so large and so gravitationally significant that it challenges the very definition of what a satellite is, and makes a strong case for being considered a planet in its own right. To understand this argument, we first need to look at the official definition of a planet. In 2006, the International Astronomical Union established 3 criteria that a celestial body must meet to be classified as a planet. First, it must orbit the sun. Second, it must have enough mass for its own gravity to pull it into a nearly round or hydrostatically stable shape. And third, it must have cleared its orbital neighborhood of other large objects. So how does our moon stack up? It passes the second test with flying colors. As we learned, its own gravity is powerful enough to have pulled it into a round, though slightly lemon-like shape. It fails the third test, as it clearly shares its orbital neighborhood with the massive Earth. And it seems to fail the first test, because we say it orbits the Earth. But this is where the definition becomes fuzzy. While the moon's primary orbit is around the Earth, the sun's gravitational pull on the moon is actually more than twice as strong as the Earth's. If you were to trace the moon's path through the solar system, it never loops back on itself. It follows a constantly weaving, but always forward-moving convex path around the sun, a path that is remarkably similar to that of a planet. The strongest argument, however, lies not in definitions but in a direct comparison. The Earth-Moon system is unlike any other in the inner solar system. The key is the moon's enormous size relative to its parent planet. The moon is over a quarter the diameter of Earth. No other moon in the solar system is that large in proportion to the planet it orbits, with the sole exception of Charon in relation to the dwarf planet Pluto. This has led many scientists to argue that the Earth-Moon system is better described not as a planet and its moon, but as a double planet, or a binary planet system. The evidence for this lies in our shared center of mass, a point known as the barycenter. In a typical planet-moon system, the barycenter lies deep within the planet itself. The planet doesn't really move. The moon simply orbits it, but in the Earth-Moon system, the moon is so massive that the barycenter lies far from the Earth's center, only about 1,000 miles beneath the surface. This means that as the moon orbits this point, the Earth does too. Our planet performs a significant wobbling dance every single month, a direct result of the powerful gravitational influence of our so-called moon. So while the official classification remains, the reality is far more nuanced. The moon is not just a captured rock or a small subservient satellite. It is a planetary-scale body, our partner in a double-planet system, forever locked in a gravitational dance that has shaped the history and the destiny of both our worlds. We have journeyed for 24 chapters through the moon's greatest secrets. We have unraveled its myths, explored its violent past, and marveled at its strange and unexpected geology. We have spent our time looking back, uncovering the story of how the moon came to be. For our final secret, we will turn our gaze forward. The 25th and ultimate secret is not about what the moon is, but about what it is destined to become. The moon is not just a historical artifact or a pretty light in the sky. It is the essential key to the future of human exploration and our ultimate survival as a spacefaring species. For decades, the moon was seen as a desolate wasteland. We now know it is a reservoir of resources that are vital for our expansion into the solar system. The most important of these is the water ice we discovered trapped in the permanently shadowed craters at the poles. This water can be harvested and processed to provide drinking water and breathable air for lunar habitats. But more importantly, it can be split into its components, hydrogen and oxygen, the two primary ingredients of powerful rocket fuel. This means the moon could become a literal refueling station, allowing spacecraft to launch from Earth with less fuel and then top up their tanks at the moon for missions to Mars and beyond. Furthermore, the lunar soil is rich in an isotope called helium-3. This element, rare on Earth, has been deposited on the moon's surface by the solar wind for billions of years. Helium-3 is a potential fuel for clean, safe, and incredibly efficient nuclear fusion reactors, which could one day provide a near-limitless source of energy for our civilization. Beyond its resources, the moon is also the perfect platform for science. The far side of the moon is the most radio-quiet location in the entire inner solar system, permanently shielded from the constant cacophony of radio noise generated by Earth. This makes it the most perfect place imaginable to build giant radio telescopes. From there, we could listen to the faint, primordial signals from the dawn of the universe, and we could conduct the search for extraterrestrial intelligence, or SETI, with a clarity that is impossible from our own world. Finally, and most immediately, the moon is our stepping stone to the cosmos. Traveling directly to Mars from the surface of Earth is an immense challenge due to our planet's strong gravity. The moon, with its low gravity, only 1/6 of Earth's, is the perfect training ground and staging post. It allows us to test the technologies, habitats, rovers, and life support systems we will need for a multi-year mission to Mars in a location that is only a 3-day journey from home. This is the entire purpose of NASA's Artemis program and the International Lunar Gateway space station. They are not just about returning to the moon. They are about learning how to live and work on another world, building a sustainable presence that will serve as the jumping-off point for sending the first humans to Mars and beyond. The moon has transformed in our understanding, from a mythical face in the sky to a geological marvel, and now to an essential and practical part of our future. The greatest secrets the moon still holds may be the ones it will help us unlock about the rest of the universe and about our own potential as a species. Our first journey to the moon is complete, but our journey from the moon is just beginning.